let's talk about how the periodic table is organized. Being able to read the periodic table, look at it and understand what it is telling you is a great way of being super successful in chemistry. Because if you look at the periodic table and you know what it means, it can give you a lot of the answers that we need. Family names, a period, quantum numbers, number of electrons, number of protons, atomic masses. It can tell you your charges. It can help you even find electron configurations. All that information is just provided for you on the periodic table if you understand how to look at it and decipher the information. And so we're going to start working through that today on the organization of the periodic table. It's a great way of helping you organize chemistry knowledge. So we arrange a table in two different ways. And so when we're talking about things, we're either talking about the columns, those are the up and downs, which are your groups, also known as families, or we're talking about periods, which are known as rows. So if it goes horizontally, or we're looking left to right, you're in a period. If you're looking up and down, that's a group or a family. There are 18 different groups, and the groups and families of elements have similar properties. So groups and families are elements that have similar properties, whereas rows, these are elements that repeat properties. There's a total of 7 periods and 18 groups and families. Groups and families are synonyms in chemistry. So then we're going to look at periods. I know this one only has 6. I couldn't find one with 7, but it was a really pretty representation of this is what a period looks like. It goes left to right, rows. So let's name or talk about how to name a periodic family. It's your first element plus family. The difference is columns 1 and 2 have unique names, and columns 17 and 18 can either be named as above or they can utilize their alternative names. I'm going to give you all the names. And then you have your inner transition numbers. You name that your jump down element plus either you have your lanthanide series, which is your top row of your inner transition metals, or you have your actinide series, which is the second row of your inner transition metals. We're going to cover all of this in a second. So let's look at the representative element families and their elements. These represent the wide variety of physical and chemical properties of the periodic table. So the first column, column 1, is called the alkali metals. Column 2 is alkaline earth metals. These first 2 columns are your first 2 of the representative elements. There are 8 representative elements. Column 13 is your boron family. Column 14 is your carbon family. Carbon 15 is your nitrogen family. Carbon 16, column 16, is your oxygen family. Column 17 is your halogen family or your fluorine family. We generally call them the halogens in this class. And then column 18 is your noble gas family or your helium family. We pretty much call them the noble gases in this class. These 8 columns, 1, 2, 13, 14, 15, 16, 17, and 18 are your representative families and elements. Do I have any questions? Then we can talk about a great visual is this right here. I would recommend taking a screenshot of it if you want a nice look at all the groups and their names. I'm using this as a screenshot. I just covered this information, and I'm going to now cover the transition and naming of the transition and inner transition metals. So column 3 is the scandium family. Column 4 is the titanium family. Column 5 is the vanadium family. Column 6 is the chromium family. 7 is the manganese family. 8 is the iron family. 9 is the cobalt family. 10 is the nickel family. 11 is the copper family. And 12 is the zinc family. The first row of the inner transition metals is the lanthanide series, and the second row is the actinide series. The important thing to know is that you do not necessarily have to memorize any of the family names. If you look at this column here, the first element is going to be scandium. The first element on this column is going to be titanium. So outside of columns 1, 2, 17, and 18, you name them by the first element in that family, and then you write the word family. Here's an easy breakdown if you just want a nice chart of all the families in the transition metals. We're going to talk about some periodic blocks, and I made this. It's a nice breakdown of both representative elements and what quantum numbers are. We can look at the periodic table as either elements or elemental blocks. Both sets of information give you really critical information. The S block, which is the green, can only hold 2 electrons, and therefore it's 2 columns wide. The P block, which is this blue block over here, can only hold 6 electrons, therefore it is 6 columns wide. The green block and the blue block are your representative elements. The D block can hold 10 electrons, and it is 10 columns wide. And the F block can hold 14 electrons, and it is 14 columns wide. The D block, which is purple, is your transition metals, and the F block, which is orange, are your inner transition metals. If we're going to look at the quantum number, that's also your period number. That really only is specific for your representative elements. So green and blue, or S and P, when we're talking about quantum numbers, that's when it equals the row number. So there's 7 rows, so there are 7 primary quantum numbers for D and F, and we'll go through this in the future. The number for it is the quantum number -1 or quantum number -2, but that is too advanced right now. I just really liked this visual. It's something that I usually have students draw out because it's really important. So I wanted to show you this periodic table. I really like it. So when we're looking, and I'm talking about, look at the periodic table, the first row, and then the name. See how scandium is the first element? So scandium family. Titanium's the first element, titanium family. Vanadium's the first element, vanadium family. Boron's the first element, boron family. That's how you do the name. The only difference is for the alkali metals, alkaline earth metals, the halogen family, and the noble gas family. Here's another great representation of the periodic blocks. Look, you have the quantum number in front of the block number. So S, 1, 2, 3, 4, 5, 6, 7, and P, 2, 3, 4, 5, and 6. These two we'll discuss later, but here's D and F. We'll be looking at this periodic table, again, when we're talking about electron configurations, in 2 units. So this is 2 units away, but because we're looking at different ways of looking at the periodic table, it was critically important that I show you this information. So let's talk about the proper name of a transition metal. I don't know how to do this, and I'm sorry, I didn't know that it tells me where my missing slides were. Okay, so let's talk about the S, P, D, and F block elements. So S and P is the S orbital holds a maximum of 2 electrons and it spans 2 groups. We looked at that already. That is your green block. The P orbitals hold a maximum of 6 electrons and span 6 groups. That was your blue block. S and P are your representative elements. D and F are your transition and intertransition metals. D contains metals. It is the largest block and it holds 10 electrons, spans 10 groups. And F holds 14 electrons, spans 14 groups. If you're wondering why D is larger than F, it's because D is both 10 long and it's about 4. So it's got about 40 elements in D, where there's only about 28 total elements in F. And then we're talking about principal energy levels. This is the same thing as a quantum number or a row number. And these principal energy levels are primarily for the S and P blocks, or the representative elements. F and D have different sublevels. And that's the basics of how you read a periodic table.